Welcome to Bell Institute for Learning. Now let us see what is Venn diagram. Okay, Venn diagram. What is a Venn diagram? It's nothing but just a diagrammatic representation of a set. It is the diagrammatic representation of a set. That is to say, let us take an example. You have a set A which contains these elements 1, 2, 3, 4, and 5, and you have one more set B which contains 2, 4, 6, and 8. These are the elements present in set B. How to draw a Venn diagram? Let us see for the above example. Okay, how to draw the Venn diagram. First, draw a rectangle. Okay, draw a rectangle, and this is called the universal set. This contains all the elements present in A and as well as in B. Okay, and then you can draw a set A and set B. Okay, and write all those elements in A. 1, okay, 2, 4, 3, and 5. Here you have 6 and 8. Why have I drawn like this? Because this 2 and 4 is common to both the sets A and B. This 2 and 4 is present in both the set A and set B, right? So it's common to both. So it's written in the intersection of the two sets. I have mentioned about the intersection of the two sets in the previous class. Now let us see an example for mutually exclusive set. Okay, let's draw a Venn diagram for this. This is the universal set. Okay, and this is set A, set B. Okay, if there are no items which are common to both, then this is called mutually exclusive set, because their intersection is a null set. Here A intersection B is a null set or a void set. There are no elements which is common to both the sets. Okay, now let us see one more example for complement of a set. Complement of a set. Let us draw the Venn diagram for this. This is the Venn diagram I'm drawing here. Universal set, and you have a set A. Okay, set A, then this is A complement. All those elements which are in A are called set A, and all those elements which are not in A called A dash. Okay, now let us see De Morgan's law. De Morgan's laws. Okay, first law says that if there is a set A and set B, when you take the union of the two sets and take the complement of that, then the complement of set A intersection complement of set B, these both are equal. Okay, that means to say, let us see this inverse. The complement of union of sets is intersection of the complements. Okay, this is the first law of De Morgan. Now let us see the second law. I'll just mention both the laws. There are two laws, De Morgan laws, first law and the second law. I'll just mention both the laws here and then I'll give you the example on each one. Okay, the second law says that you have set A and set B. Then when you take the intersection of the two sets and the whole complement, then it will be equal to the complement of set A union the complement of set B. This is the second law. And in words, if we want to put it across, then the complement of intersection of sets is union of their complements. Union of their complements. Okay. Now let us see the example. Now let us see an example on how to verify De Morgan's law. Okay. There's a question saying that verify De Morgan's laws if it is given that a universal set which contains these many elements 10, 20, 30, 40, 50 and 60. Okay, and you have a set A which contains 10, 20, 30 and 40. You have a set B which has the elements 20, 40 and 60. Okay. Now let us see the solution for this. How to verify. Let us see that. Okay. We know that A dash, that is A complement, is equal to U minus A. Let us find out that set A complement. What is that? All those elements which are not in A but in the universal set. Okay, what is that? 50 and 60. You can see here 10, 20, 30, 40. So 50 and 60 are the two which are not in A but in universal set. You got A complement. Similarly, you can find B complement. What is B complement? Which is not in B but in the universal set. What is that? You have 20, 40 and 60. So 10, 30, okay, 10, 30 and 50. This forms the complementary set for B. Now, what are the other things we need to verify the law? You need to know A union B. What does the first law say? First law, De Morgan's law. What does that say? What does that say? First law of De Morgan's law say A, you have A union B, the whole complement is equal to A complement intersection B complement. This is what we need to verify now. Okay. So for that we need to find A union B. What is A union B? Both elements in A and in B. Okay. That is, you have 10, 20, 10, 20, 30 and 40 and 60. Okay. Now let us find the complement of this. A union B the complement. All those which are not in this but in the universal set. What is that? Just a singleton set. What is that? 50. Okay. Now let us find A dash intersection B dash. A dash intersection B dash. What is that? That is again 50. That is, which is present both in A dash and B dash, is the only one number that is 50. A singleton set. Okay, sorry. So what does that mean? First law says that A union B the whole complement is equal to A complement intersection B complement. So LHS is equal to A union B the whole complement, which is equal to 50, which is equal to RHS, which is equal to A dash intersection B dash. Thus, first law, first De Morgan's law verified. Right? Now let us verify the second law. What does the second law say? A intersection B, the whole complement is equal to A complement union B complement. Okay, let us verify this. For this, you need to first find out A intersection B. What is A intersection B? In this case, you know what is A. Okay, A intersection B is 20 and 40. Right? 20 and 40. A intersection B is 20 and 40. Let us consider the complement for that. In the universal set, other than 20 and 40, all elements are present in the complement of this. What is that? 10, 30 and 50, 60. Okay, this is A intersection B, the whole complement. Now you have A complement union B complement. Okay, what is A complement union B complement? That is, you know A complement and B complement, right? You have A complement 50 and 60, B complement 10, 30, 50 and 60. This form the union of the two sets, A complement and B complement. When you go back and see, you can see that union of these two sets is this. Okay. Now this proves that in the second law, LHS is equal to RHS, right? LHS is equal to RHS. See? Thus, second law is verified. Subscribe and press the bell icon to learn more. Like if you are satisfied. Share to spread the knowledge. Write the doubts, if any, in the comments section. Thank you.